Trig equations. So this is going to be, each question is in two parts, and it's going to make more sense as we go through it. The first thing I'm going to have you do is find all of the angles, if there are any, that will solve the equation where those angles are between 0 degrees and 360 degrees, which is one round around the unit circle. You have already solved for equations where you're given sine theta equals 1 or cosine theta equals root 3 over 2, something like that. So now we're going to combine your algebra abilities with those newfound unit circle abilities. Your first job is to isolate the trig function. That is the algebra side of this. So if I'm going to get cosine theta alone, what do I need to do to both sides of the equation so that cosine theta is alone? And I want to see it in chat. I want to make sure I'm not alone here doing the problems all by myself. Right. So if I divide both sides by 2, I get that cosine theta is equal to 1/2. It's isolated. And now it's time for the unit circle. If I'm dealing with cosine, is that the x or the y coordinate of the unit circle? Good, the x. So if I replace cosine theta with an x, and then I say, okay, draw the line x equals 1/2, you're going to draw a line that is vertical. And then you want to remember what the special numbers are along the x and the y axes. And the special numbers are, as you go away from the origin, 1 over 2, root 2 over 2, root 3 over 2, before hitting 1. So this 1/2 is the first of those 3 numbers away from the origin. There are 2 more of them. You can use that to realize that that means that this angle is the one that is 2/3 of the way through quadrant 1, because with these other 2, I've got a middle one that's halfway through and another one that is 1/3 of the way through. It helps sometimes, though, if you do have a unit circle to draw on. And that's why, where are we? Come on, go there. That's why for some of these beginning problems, I have them drawn out in this way to help you to think in that manner. But then you reach a point where you start needing to draw your own circles. So just looking at this circle that's right in front of you, I want you to see that if x equals 1/2, you also have the root 2 over 2 and the root 3 over 2 for these particular 3 vertical lines. So what angles does that give us? What are those 2 angles where the cosine is equal to 1/2? Yep. 60 degrees and 300 degrees. And you can see that if you look at the fact that up here is 90, down here is 270. And so it's 30 degrees before 90 and 30 degrees after 270. So I'm going to go back over here and I'm going to write down that the answers are 60 degrees and 300 degrees. And just to point out what's going on over there as well. Okay. Number 2. How far do you think you can get with that on your own at this point? The first step is the algebra, and the algebra is isolating the trig function. So I'm going to circle the trig function. What do you need to do to isolate it? For this particular problem. Good. Subtract 1. That gives me the equation sine theta equals -1. And now the algebra part is done, and I'm on to the unit circle. When I'm working with sine, does sine represent the x-coordinate or the y-coordinate? Good, the y-coordinate. So what you can do is draw y equals -1. That's a horizontal line, and a horizontal line at -1 is at the very bottom of the unit circle. It's the lowest that circle will go. Now that means I only have one angle, and that angle is 270 degrees. Now I just remembered that in part 1 I actually only did part A, not part B. So I'm going to do part B with both of them. First of all, for number 1, the answer to part A, we got 2 angles in one round around the unit circle. For number 2, I'm only getting one angle answer as I go around the unit circle. If I want all solutions, that means I'm looking for all angles that are coterminal with the ones that are on the first round. How do I find coterminal angles? I add 360 or I subtract 360 any number of times. And why did I go number? Because typically in trig equations, we use the letter n to represent, to represent all integer numbers. And just to clarify and make sure that you've got it, an integer includes 0, 1, 2, 3, 4, forever. And what else does it include? Negative numbers. So nice numbers that can be written as non-fractions or without really nice ones. So this is what n is representing. Now, the traditional way to write this mathematically is to put little set brackets around it. But the thing that you need to understand is n, we're about to use it. It represents all of those numbers at any time, at any moment. And that allows me to write the answer as, for number 1, and I'm going to erase this circle right here because it's in my way. If I take 60 degrees and I add 360 times any integer n, or if I take 300 degrees and add 360 degrees any number of times n, that will make my full solution. And I'm okay with you leaving your answers just as a list with a comma there. I'm not going to make you write it in like full mathematical notation because that is enough where you show me you understand what those answers are. Now, I want to warn you that some of these problems will simplify further, but I'm not going to expect you to simplify them further unless you want to. At this stage, I don't want you to get overly concerned with simplification. I want you to focus on why the answers are correct, the way that they are written. So in number 2, 270 is the only angle on one round of a unit circle that solves that equation. That means in part B, the only thing that solves that equation is something in the form of 270 degrees plus 360 degrees times any integer, any number that is an integer. All right, now we're going to get a little bit harder. I'm going to have you start with the algebra of isolate cosecant. And you need to be familiar with a particular notation. And it's very frustrating. Are you ready to talk about this issue? And I'm going to actually write this to the side because I want you to just listen to what I'm saying about notation. If I write a trig function and as a superscript, I have a positive number and then back to the same line as the trig function, I have an angle. And this goes with any of the 6 trig functions and any positive number. This means the same thing as the sine of theta as a function's, as an answer to sine theta being squared. Now, mathematicians have sometimes been accused of being lazy because shortcuts for writing get created because they get tired of writing parentheses all the time. So they came up with this great idea of, hey, let's put an exponent there for trig functions so we don't have to keep writing parentheses and then an exponent, because you know we do this a lot, having trig functions with exponents. It's a common thing. Then somewhere, most likely with somebody else decided to write inverse trig functions in a way. And I'm going to talk about this again later, but I want to emphasize something to you. When you look at your calculator, do you see a button that has a little -1 on a sign? And we've used it before. That -1, if you remember when we used it on the calculator, we were using it to go backward in the function, to do the inverse function, to go from the answer to sine to the angle. That does not mean sine to the power of -1, and you need to know that. That is very important that you know that. And I'm going to emphasize it right now, and I'm going to emphasize it again when we run into this some more. This does not equal sine theta to the power of -1. This means an inverse function. If I put a parentheses and a -1, then I'm really talking about the reciprocal function. Reciprocal and inverse are not the same thing. Unfortunately, a lot of people get frustrated with math because sometimes the notation ends up confusing people and they don't know what they are doing wrong when it's not actually them doing the wrong thing. It's the fact that there were some very poor judgment calls made on how we were going to write things. This was a very, very poor judgment call, because you need to understand that when the superscript shows a positive integer, that does mean exponent. But when you see a -1, and we never write negative integers on our trig function, that does not mean the same thing. For today, you're not going to worry about the -1 piece. But I need to point it out to you so that the second or third time that I point it out to you, it might stick a bit better, that this is just a really bad notation choice. These two are different notations for different things. And again, it's a poor choice. So when you read on number 3, the superscript 2, come on, zoom in. Oh, now you listen to me. Okay, stop lag time. You want to know that what this is saying is cosecant of theta squared. Textbooks will never write it this way. But that doesn't make it incorrect to write it this way. It's just not the standard notation that will be used and put in print. So how do you undo a squared? You square root. And let's remember back really, really, really long ago. Do you remember what you have to remember to do when you take the square root of both sides? Good, plus or minus. What that means is we get the equation cosecant theta is equal to plus or minus the square root of 2. Now, what I recommend that you do at this point, if you have cosecant or secant or cotangent, reciprocate them. And then you only have to know how to work with 3 functions on the unit circle. If I reciprocate cosecant, that is which trig function? Good. And what I'm going to do is say reciprocal of the left side is sine. The reciprocal of the right side is 1 divided by what you see on the right side. Do you recognize 1 over root 2? If you do, that is fantastic for you. If you don't, I'm going to keep throwing this your way until it just sort of sticks. If I multiply numerator and denominator by root 2, I get root 2 for the numerator. And then in the denominator, when I multiply root 2 times root 2, I get 2 in the denominator. And that is the middle of the 3 special numbers on the x and the y axes. Now we have found where we need to look on the unit circle. So all of that was the algebra part. Now we turn to the unit circle. is sine representing x or y? So that means I need to draw two lines. One is positive root 2 over 2, one is negative root 2 over 2. And when I draw y equals, it's a horizontal line. And I know that there are three special numbers where y is positive between 0 and 1, and three special negative numbers on the negative side of the y-axis between 0 and -1. And I know that root 2 over 2 is the second of the three. And notice I emphasized 2, root 2 over 2, because it's root 1 over 2, root 2 over 2, root 3 over 2. And I figure if I say this over and over again, it's going to help it to just start sinking into your head without you having to try quite as hard. All you have to do is pay attention, and it's going to make a big difference for you. So I'm drawing that horizontal line that is the center of these three, or the second of them, and then this one down here. That gives me 4 different angles as I go around the unit circle one time. What are those 4 angles? Good. Excellent. Good. So these are all of the angles that actually make 45-degree angles with the x and y axes. So we've got 45 degrees, and then 90 plus 45 gives us, let me see, I just saw it, 135. Boing. And then 180 plus 45 gives us 225. And I'm going to draw for the 225. And then lastly, for 315, which you can look at as 270 plus another 45, or you can look at it as 360 minus a 45-degree angle. So those are all the angles that I get with one round. Now, I want to show you what I will accept as an answer to part B, and then I'm also going to tell you what the most simplified form is that you can write if you so want to, but I'm not going to push it for this class. So for part B, you can just take the angles that you got from part A, list them. 35, 225, 315, and then add to each of them 360 degrees times any number n. And I want to say again that I accept that as completely correct. Does anyone see that there's actually, yeah, that's what I was about to say. There is actually a shorter way to write it, but I wanted to first show you that you can take your answers no matter what equation you begin with. Take all your answers from part A, list them, and throw on a plus 360n, and you have correctly given an answer to all the angles possible. Then when you feel strong enough, you can go ahead and simplify further, because with this problem, if I start at a 45-degree angle, I will reach all other angles by adding 90 degrees any number of times that I want. So the simplified answer is 45 degrees plus 90 degrees times any number that is an integer. And that's pretty. It's really nice. So we have only 2 more problems left in our classwork. How are you feeling? Is it feeling doable? Now, excellent. Now I'm going to help you out with these next 2. You wrote, yeah, I wrote 45 plus 90n. Oh no, you actually don't need to write plus or minus on that 90n. Let me first of all clarify that plus or minus, we did get a plus or minus sign when we did the square rooting. And because of that, we got not only these 2 angles, but we also got these 2 angles as well. When it comes to the n is representing both positive and negative numbers all at once, so you don't have to put plus or minus with it. There's an understanding that it's an equation based on n representing all integers, including 0, because 0 is your first trip around the unit circle. When n is 1, you have already made 1 journey around the unit circle and you're on your second journey. When n is 2, you're on your third round. When n is -1, you're on your first round in the negative direction. So this takes care of any number of times around the unit circle in either direction to get all your coterminal angles. Listen carefully to the directions I give you with numbers 4 and 5, especially with 5, you're going to find it very helpful. Now, if you want, cosine, does it represent x or y? Does cosine represent x or y? Mm-hmm. So what you can do is you can temporarily say, hey, let's call cosine theta x. That means that this is now 2 times x squared minus 1 equals 0. If you replace the trig functions with actually any letter you want, but it's nice to keep talking about x and y as associated with cosine and then y with sine. And you can see something that looks familiar. Do you remember how to solve this? And you've got a couple of options. How do you algebraically solve this? Factoring is one way. Get rid of the 1 by doing what to it? You got it. That's the other way to do it. The dread quadratic formula, only if you're really in a tight spot. Most of you will see this most easily if I do the add 1 first. I only have x written 1 time. If you ever have your variable written only one time in an equation, you can solve the equation by going through an isolation process. So we add the 1, then divide by 2, and what's the next step? And what do you have to remember when you take the square root? Good, plus or minus. That means I've reached the point of saying x is equal to plus or minus the square root of 1/2. Now, do you recognize that number again? And this, as soon as you recognize it, go with who it is and just start heading over to the unit circle. I'm going to write this until you see it. I can distribute the root over division. And the square root of 1 is 1. And do you recognize it at this point? If you don't recognize it at this point, rationalize the denominator by multiplying numerator and denominator by root 2. And now I have root 2 over 2. At any point along that entire line that you recognize that it's the middle of the 3 special numbers of the unit circle, you don't need to write that number in any particular way. You just need to use that number to get the correct angles. Now, at this point, you have solved the algebra part. I need to now go back and remember who I'm working with. I'm working with cosine, which I represented by x to kind of help me in remembering that I'm working with cosine. So realize that ultimately what you're actually working with is not x equals, oops, there we go, not x equals plus or minus root 2 over 2, but technically I'm working with cosine is equal to plus or minus root 2 over 2. But I use the unit circle remembering that cosine is x. And now I can draw vertical lines. Positive root 2 over 2 is the middle one. Negative root 2 over 2 is the middle one on the left side. And does this look like something we got just a moment ago? We're actually ending up with the same exact answers we got in number 3. It's just we got to them with vertical lines instead of with horizontal lines. Come on. So that gives me letter A is 45, 135, 225, and 315. And then for letter B, the answer is all 4 of them with either plus 360n or the simplified version. And now we have only one left. And for this problem, I would strongly recommend replace sine theta with a letter. You can use any letter you want to help you out. If you look at the classwork answers, what did I use? Or maybe I didn't use it there. Okay, I didn't. It helps to use the letter Y to represent sine theta because it keeps reinforcing the issue that the Y coordinate is the same thing as sine theta. This is extremely, extremely important if you to get a hold of. If you are going further in math toward the calculus side, or if you are wanting to do physics, trig functions are very, very important in physics because physics has it's got a few waves involved. Just a few. So I'm going to write y instead of sine theta. That means that this will be 2y squared minus y equals 1. And now you have a quadratic equation, and you're going to use algebra to find the solutions for y, and then you're going to use the unit circle to find the angles. What's the first thing I need to do with a quadratic equation before I factor? I'm watching chat. Yes, make one side equal to 0. I'm going to subtract 1. And now I can factor. Let's see how everyone's doing with factoring. Do you want me to talk through the whole factoring process with the diamond and the square? Or is that too much? I'm just waiting to get a response so I know that what you need. You do you. Okay. Everything I'm doing right here is for you. I'm not doing it for me. Okay, thank you. I just needed to know if you guys were at a point where you okay, here we go. I'm dealing with, if you remember the diamond, you multiply A and C and you put B down below, where you have coefficients A, B, and C. So A is 2, C is -1, and B is -1. You need to find two numbers that when you multiply them, you get the top number, and when you add them, you get the bottom number. Can you think of those numbers? And not quite yet. You're close with that. So right now, just two numbers. If I multiply them, I get -2. If I add them, I get -1. Good. -2, +1 are the numbers that we were looking for. That means as I go about factoring 2y squared minus y minus 1, and I make my box for multiplication. I know that inside I have my leading term, my constant term, And then the middle term is split up in this manner. So for those other two boxes, one of them is going to be negative 2y, the other one's going to be positive 1y. And you can put them whichever place you want. And then it's a matter of thinking what are common factors within a particular column or within a particular row. Let's look at row 1. What can divide both of these terms in row 1? I've got a 2y squared and a y. What can divide both of them? Good. And, then you can pick something else, like let's pick column 1 this time. What can you divide both of those? What will divide both of them? 2y. And then recognize 2y times y will give us the 2y squared. And now we're almost there. What is the number that goes in the blue spot that I just highlighted? Uh-huh. 2y times negative 1 will give me negative 2y. And I apologize, colorblind folks. The green region, what needs to go there? Right, positive 1. Because I need something that will multiply to y and give me y. And I need something that will multiply to negative 1 to give me negative 1. So I've now factored, and I can see that I have a 2y plus 1 and a y minus 1. And now what do I do to finish solving the algebra? What do I do with 2y plus 1 and y minus 1? And then once I have them in the parentheses, what am I actually doing to solve? Find what makes them equal 0. Because I have two things multiplying that give me 0, one of them has to be 0 in order for that to be true. And that gives me y equals subtract 1 and then divide by 2, and y equals add 1, and the algebra part is done. Once the algebra part is done, then you turn to the unit circle. We wrote y because we were dealing with sine theta. So I want to rewrite sine theta just to emphasize that that is our focus. Sine theta is equal to negative 1/2, and sine theta is also equal to positive 1. Sine is a y value. And now in the unit circle, I'm drawing horizontal lines at y equals negative 1/2, which is the first of my special numbers in the negative direction. And y equals positive 1, which is the top of my circle. For the y equals negative 1/2, That means that I am 180 plus another 30 degrees. And then 360 minus 30 degrees. And over here, that's 90 degrees. There are 3 answers when I do one round around the unit circle. If I want to write all possible solutions to that equation, then I can list these and add to each one 360 degrees times any integer n. And if there's a simpler way to write this, you can. What do you think? Is there any possibility of a simpler way to write this? And how would I figure it out anyway? I think what I should do is I should go over to a circle that is actually drawn and point out these angles. We have our 90-degree angle here. And then we also had angle 210 and angle 330. Just step back and look at that. Do you see anything? Do you see anything when you step back and look at that? Yes. It is cutting the circle up into thirds. So I can actually write this. I can start at 90 degrees. How much do I add to 90 degrees to get over here? Yep. 120 degrees is 1/3 of 360. I go another 120 degrees, and that takes me to 330. And can you see that this is another 120 degree turn to go to 90 plus 360, the coterminal angle there. So the answer can be simplified to 90 plus 120 degrees times n. But I want to reiterate, I am okay with all of you if you want to write the answer in this format. Once you start seeing more, you can write the more simplified version. And if you are going to end up using Trig somehow, you're going to be going on to the next math class. And in that math class, you want to reach a point where you do feel comfortable seeing the simplified version. So, how's that? Not too bad? This concludes everything that is going to show up on your first trig test. Right. That's though why I changed our calendar to give us a few days of reviewing everything we've done. And I want to point out to you that in the homework, you're going to be solving some trig equations. And then I'm going to have you doing more graphing like you did yesterday. And then tomorrow, I'm going to spend a lot of time focusing on using the unit circle and feeling comfortable with it for forward as well as backward. And then you will be ready for a quiz coming up on Thursday, I think is where I put it. Let me double check that. Yes, I put the quizzes for the forward and the backward on using the unit circle on Thursday, and that gives us another day tomorrow to get that nice and secure. And then I can review it on Thursday with you before you go into the quizzes. Meanwhile, we need to review the graphing that we learned yesterday and the solving equations, and that you'll quiz on Friday. And then I feel like you need the weekend to process this stuff before going on to the test. So let me stop recording.